This is the section on matrices and inverses. Starts out with an interesting story. During World War II, Sir Alan Turing, a now famous mathematician, was instrumental in breaking the code used by the Germans to communicate military secrets, and so on and so on. Apparently, this has to do with matrices and their inverses. And if you look at lectures and homework in my Blackboard channel here and scroll a little bit down, right behind matrices, it says the Imitation Game official trailer, which is about the Enigma machine and how Alan Turing and some other mathematicians cracked it and helped the English avoid more casualties. And so, happy coincidence that I have it here? No, of course not, because that one, of course, totally relates to apparently matrices and their inverses. All right, so let's look at this one here. And first of all, what they're going to start out with is what's called the identity matrix. And the identity matrix always has 1, 1, 1, 1, 1 in the main diagonal, and everything else is 0. Doesn't look much if you only have a 2 by 2 matrix. But let's see what else happens. So they're playing around a little bit with the identity matrix. If you multiply by any kind of matrix, you come up with the same thing. That makes sense. It's as if you multiply something with 1. It's the same thing. Then, okay, here it is. The main diagonal is all 1s, and the rest is all 0s for the identity matrix. Okay, what does it have to do with the inverses? Well, it's coming up here. So here they're starting out with, look, if we have the inverse of a number a, which is 1 over a, and multiply the two of each other, we come up with 1, which is the identity number. So the same thing ought to happen if we have two matrices, a matrix A and a matrix B that happens to be its inverse, then we should come up with the identity matrix. And that's what they do here. They lead us through the motions, and they're going to show us here, first of all, let's see, I thought they had an example here. No, they actually show us right away how it's done. They're using an augmented matrix where they put the identity matrix right behind the original matrix. So they make this one up and figure out what the inverse is. And then they use the Gauss-Jordan elimination, which means you get all 1s here and 0s here, and then some stuff happens on the other side as you multiply here, for example, with 2, and you add it to the second row, and so on and so on. And then eventually you come up with this. -5, -3, -2, -1 apparently is the inverse matrix. And that's how it's done. So it's quite a complicated process because you have to keep track of a lot of numbers. Notice this one here, checking if two matrices are inverses of each other. That's actually what I was thinking about a moment ago. And you have to keep track of, wow, 9 entries here and 3 each. So 27 multiplications and additions and so on. Wow, quite a bit. All right, and then they keep on going here, and they just more examples on the same thing. And then towards the end, I really like this last example here, which you will also find on the study sheet for the exam. And so here it says, suppose you receive an encoded message in the form of these two 4 by 1 matrices, -30, 26, 109, -81, and so on. And it says it's encoded. And the original message was that this is, or the original message was actually encoded by using this matrix. Now, of course, if you have your counterpart in the cryptic business, they would have to know what that original matrix is in order for them to figure it out. So what you're telling them is, hey, here's the original matrix, here's the encoded message, only you know what the original matrix is. Take the inverse of it, which is what they're doing here. I think, nope, they're not showing it how it's done. They just say, hey, we did it. So here, this is the inverse matrix here, a to the -1 of the original matrix A. And then they multiplied one at a time with these other encoded messages, and they come up with these here. And if you look at the video for the study sheet for the exam, you can see how that is neatly done in Symbolab. Never mind, I will put it in right here. In fact, I'm going to multiply this inverse matrix here with both of these 4 by 1 matrices at once. And when I go over here to Symbolab, you can see how I plug that in. So here's that to the -1, which is the inverse. And that, oh yeah, that one actually is the original matrix. So this is to -1. multiply with these two 4x1 matrices. And it's doing it. Here, by the way, this one right here is that inverse matrix after the original one was inverted. Still times these two matrices. And this one here then is the same solution that we see in the book. 8, 5, 12, 16, 0, 13, 5, and 0. And here they are, right? So this is the decoded message. And apparently when you look at the alphabet, and you assign 1 to A and 2 to B and 3 to C and so on, you can decipher this as HELP. This one means space. ME, help me, would be the message. And that's what I got for this section on inverses of matrices.